Hi guys, I hope y'all are doing well. I'm gonna go ahead and help you with chapter 6. I'm gonna leave number 1 up to you guys, and I'm gonna start with number 3. So, number 3 says, assuming random sampling is from normal distribution with standard deviation of 5, if the sample mean is x bar equals to 45 based on n participants 25, what is the 0.95 confidence interval for mu? Okay, so for this one, first we have to get that C constant, which you can find in the table, but if you're wondering how to do it, I did 1 plus, it was that confidence interval 0.95, and then you just divide it by 2. So this is the number that you're looking for, that confidence interval in the table 2.1. And I think for that one, there's also a little shortcut on page 143 where it gives you all of the confidence intervals, 0.90, 0.95, and 0.99, and it gives you the corresponding values for that, the C's. So in this case, it's 1.96. So we're going to go ahead and do the formula that is on page 142, I believe. And it basically says x bar, which is 45. It's going to be plus or minus, but we're just going to do it at a time. So we're going to do minus, then it's that C, which is the 1.96 confidence interval, and it's times, I'm sorry, is it? No, hold on, not yet. Yes, right? Times 5, which is that standard deviation, and then, wait, hold on, I think it's like this. Number 3, which is 43.04. Let's try it the other way. Because 1.86, and then in this case it would be times 5 because the standard deviation is 5 times 5, and then divided by the square root of n, which would be in this case of, I believe it is 25. I just want to see what I get. Okay, yes, I get the same thing. So this is the formula here for them. So then I would do the same thing again, but it's going to be plus. We're getting 2 confidence intervals here. Okay, so this is basically the standard deviation, just to go over it again, since I know I did it in my head. So it's 45, which is the x bar, plus the confidence interval, which is, or the C is 1.96, times the standard deviation. In this case, it's 5, they give you 5, and then it's divided by the square root of the n, which is 25 in this case. And we're just going to switch it. We did minus on this other one, and now we're going to do plus. Enter, and it should give you the other into that one. So then you would write there, it is 43.04 and 46.96. That's the confidence interval. Okay, so now we're going to do number 4, which is basically the same thing, but now we're going to compute that 0.99 confidence interval instead. So if you go again to 145, you have a little chart there. You can get it, the C is going to be 2.58 in this case, but you could also do, again, the 1 plus so you guys know how to do it. 0.99 and then just divided by 2 should also give you this number here, and then you would just look for this number on the table and should give you that 2.58. Okay, so then for this next one, we're going to do the same thing. So again, 45 is X bar, plus or minus, in this case, first one we'll do minus that 2.58, which is a constant. And then we're going to do times the standard deviation 5, and then divided by the square root of 25. So this should give us 42.22, okay? And then you just want to press that up arrow so you don't have to write the whole thing all over again, and then just switch this one to plus. So plus and minus, there you go. So you should get 47.58. So that is your confidence interval there from you. Okay, so then we're going to move on to the next one, which is number 6. It says compute a 0.95 confidence interval for the mean assuming normality for the following situations. And it gives you all of the A's, n is equal to 12, standard deviation 22, and X bar of 65. So we're going to do this, basically, we're going to get that, let's see. We're going to do the same thing here. Now they're just giving us new numbers. So the first one says X bar is 65. So 65 minus, plus or minus. In this case, it's a 95 confidence interval, so that one should be 1.96. 0.96 times, so the standard deviation in this case is 22. 22, and then divided by the square root of the n, which in this case is 12. Okay, so enter, and that's your first range, 52.55, and then up arrow, and I just switched the minus the positive for adding. And then that's the other one, 77.44. Okay, so then that's the first part. And now letter B is X bar is 185. 185 minus, again, this one is the C, which is 1.96, as we're doing that 95 confidence interval. So minus 1.96 times, in this case, the standard deviation is 10, and then the square root is 22. Okay, so enter. So the first one is 180.82, and then again up arrow, and I'm just going to switch this one to add. So then it's going to be 1.89.17. Okay, so the last one on this one, X bar is 19. 19 minus 1.86 times the standard deviation, which is 30, divided by the square root of n equals 50 in this case. Okay, so it's going to be 10.68, and again up arrow, and I'm just going to do the same thing. Here, plus, and the other range is 27.31. There you go. So now for the next one, I think is number 10. Alright, so it says the average balance of 45 randomly selected tennis balls is found to be X bar is equal to 1.70. Assuming that the standard deviation of the bounce is 0.30, compute a 0.90 confidence interval for the average bounce, assuming normality. So we're using that 0.90, and the constant for that one is 1.645. And so we're going to do In this case, we're going to do again x bar, which is in this case 1.70 or 1.7. Is it 1.7? Yeah, 1.7, 1.70. Okay. So we're going to do minus, it's assuming normality, so we're going to use the Q norm. And this one, you just would input the confidence interval, so we're just going to set it at 0.95. This one you don't have to get the C, 0.95. Okay, so then again, kind of follows the same formula here, so times the standard deviation, which they told us was 0.30. And then divided by the square root of the n, so they said 45 tennis balls. Okay, so then that one should give you 1.62, and I'm going to do an up arrow again, and I'm just going to switch this one with the addition sign, enter, and that one should give you 1.77. Okay, so I'm going to move on to number 12. Okay, so compute a 95 or 0.95 confidence interval if, and they'll give you all the equations A, B, and C. So we're going to be doing, this time they don't give you the standard deviation, they give you the S. So we're going to do, in this case, again, X bar 26 is following the formula. 26 minus, in this case, we're going to use this one, this function QT, of that 0.95 confidence interval. You're going to use that. Let me see. We're going to use that 0.975, which is the 95 is 1 plus 0.95 divided by 2, which is, I think I have it, yeah, this one right here. So I did the same thing, I just, instead of 99, it's 95 here, which is this one, I think. So in this case, it just came, I'm just going to show you guys, because then, so it says 95, right? So 1 plus 0.95, and then I would just do divided by 2, and so we're going to use this number. So over here, again, we're going to go 26 minus QT, and here you would put that 0.975, and this one uses, I believe, degrees of freedom. So for this one, I think the formula is v minus 1, which just represents n minus 1. So whatever the n is, we're just going to subtract 1. So in this case, our n is 10, so we would use 9 here. 9 times the standard deviation, which is 9 here. In this case, it's 9. And then we're going to just do again the square root of the n, which is, in this case, it's 10. Okay. So I'm going to do the same thing, just up arrow. And I'm just going to switch this one to addition, enter, and you should get that 32.43. Okay, so we're just going to keep practicing with this next one. So in number B, or letter B, it's the x bar is 132. So minus QT, and in this case we're going to be using again that 0.975 because they want us to use a 0.97 confidence interval, and in this case it is degrees of freedom. N is 18, so n minus 1 is 17. Okay, and then just times the standard deviation, which in this case it's 20, divided by the square root And in this case, the n is 18. Okay, so if you want to just go ahead and double check that formula, I think that one was in page 147 where they go over that v minus 1. Okay, so then the last one is, okay, so this is 122.05. So that's the other range of it. And then again, I'm gonna go ahead and up arrow here. And I'm just gonna switch this one, enter. So 141 point, that one's right. And the last one, X bar is 52. 52 minus 0.975 again. And the n here is 25, so it'd be 24 times the standard deviation, which is 12 in this case. I should stop saying standard deviation with this. 12 square root of 25. Enter, and it's 47.04. And then I'm just going to go up power again here, and I'm just going to switch these. So 56.85. Okay. So we're done with that one. And now moving on to, I believe it's number 15. So rats are subjected to a drug that might affect aggression. Suppose that for a random sample of rats, measures of aggression are found to be following numbers. Compute a 0.95 confidence interval for the mean, assuming the scores are from a normal distribution. Okay. So for this one, excuse me. So x equals, we're just going to combine all of these numbers in here. So it's 5, 12, 23, 24, 18, 9, 18, 11, 36, and 15. Okay, enter. And for this one, we're just going to use that trim C. And since it's X, and that's the 20% trimmed, okay. So it should give you the confidence intervals right here. So it's these right here. Okay. Simple enough. And then lastly, number 39. Right, yes. Okay. So number 35 reads, for the following values, compute 0.95 confidence interval for 20% mean and compare the results to the 95 confidence interval for the mean. Okay, so for this one, we're going to be doing the same thing. The only difference is we're going to use the 20% trimmed mean and the one without the trim mean. So, see. So I'm just going to go ahead and put x equals, combine all of these values here. So it's 5, 60, 43, 56, 32, 43, 37, 79, 39, and 41. Okay, combine. And I'm just going to do again trim Z, X for just the mean without the trim. So it gives you here these two, the confidence intervals right here. And now we're going to do the same thing, but it's with the one that we just did right now with trim. 0, enter. And then these are the two values. So if you compare these two, they're slightly different. And I'm going to go ahead and let you guys answer the rest of that. Okay. So if y'all have any questions about all this, y'all can email me or you can text me. Other than that, have a great weekend, and I'll hopefully see you guys in class. Thank you. Bye.